The Scan&Paint system is structured in 4 tabs. Each tab is responsible for handling various tasks related to the measurement procedure and data post-processing. The order of these tabs follows the measurement procedure itself. First, the audio and video are recorded in the Capture tab. Synchronization of the captured data is performed in the Process Video tab. Afterwards, all data is being processed in the Analyze Data tab. Finally, results obtained with the system can be organized to form a report. This task can be conducted in the Report tab. Let's start from the very beginning. The Capture tab of the Scan&Paint software is used to record the scan that you perform during your measurement. Both the video and the audio acquisition are performed simultaneously. The Capture tab is divided into 4 main sub-windows: Display menu, Video monitor, Real-time signal analyzer and the controls area. The display menu contains basic options related to the video monitoring and real-time analyzer window. The first 2 options, depicted with a magnifying glass, will allow you to either zoom in or zoom out from the displayed video. This feature can also be used in the analyzer window. In order to use these tools, click on their icon. Notice that the background of the clicked button changes its color to blue. This means that the zoom-in mode is now active. You can magnify your images by either clicking on the image or drawing a rectangle around the area you wish to magnify. The zoom-out option works in a similar pattern. Please remember that in order to stop using the magnifying options you need to click on the previously selected button to deactivate it. The background of the clicked option will now change to silver. The zoom options do not interfere with the process of audio and video acquisition. In other words, even if some part of the video was magnified, the camera will still capture the full image. The next icon is the Data Cursor button. With the Data Cursor you can preview the exact amplitude at the selected frequency point. Right-clicking on the created Data Cursor will access an additional menu related to data cursors. Through this menu you can add an unlimited amount of data cursors as well as handle the way they are displayed. Buttons labeled as DB and LIN will allow you to change the data format, which is used in the Analyzer window. By default the DB mode is on. In this mode, all relevant values will be displayed in the decibel scale. Switching to LIN mode will change the display mode to linear values. The green icons on the right handle the format of the output signal you may want to generate during your measurements. The first option will generate a white noise signal on the output of the data acquisition. The second option will generate a sine wave with user-specified frequency. These options are essential if the Scan&Paint system is to be used for mapping of the absorption and reflection coefficient. For this type of measurement, however, an impedance system is also necessary. Details of such measurement procedure will be explained in another chapter of this manual. The button with a camera icon will allow you to take a picture of the image currently displayed in the video monitor. This picture can later be used as background for the color maps obtained with the Scan&Paint system. Alternatively, you can always choose any frame of the recorded video as a background for your results. However, taking a picture is the preferred option, since it will create a higher quality image. The last option available in the display menu is the Help button. Pressing this option will automatically display the Scan&Paint user manual. The next sub-window is the Video monitor. This window displays the live image transmitted from the camera connected to your computer. Before starting a measurement, it is crucial that the image displayed here covers the area you wish to study. The Scan&Paint system can only deliver results for areas visible from the camera point of view. All data measured outside of the camera view will be neglected. If the quality of the displayed image is too low or environmental conditions affect its clarity, you may choose to adjust the camera settings. These settings can be accessed through the context menu of the Video monitor window. Options provided in this window will not be discussed in detail since their setting is strictly related to specific measurement scenarios. The second option in the displayed context menu will allow you to either start or stop the video preview. This option is related only to the video displayed in this window. It will not affect the video acquisition performed during your measurement. Switching off the video preview will enhance the performance of your computer. Let's move on to the right-hand side of the Capture tab, where the real-time analyzer is located. By default, the spectra of the sound pressure microphone and velocity sensor will be displayed. You may always change the displayed quantity from the Analyzer context menu. This menu will allow you to conduct basic signal processing, like cross-spectra and transfer function calculations. Additionally, you can take a snapshot of any displayed plot or simply overlay the real-time display with a chosen instance of the plotted quantity. Double-clicking within the area of the Analyzer window will allow you to adjust the dynamic range of both X and Y axis. The settings of the Analyzer itself can be adjusted through the Edit menu. The Analyzer settings window will allow you to change the amplitude format, amplitude mode, number of FFT points, number of averages, window overlap and update rate. The influence of any of the provided parameters can immediately be previewed in the Analyzer window. Please remember that any alterations to these parameters will only affect the real-time display, not the actual measurement results. The last window located at the bottom of the Capture tab is the Controls area. Here you can provide a name under which your measurement data will be stored. The number displayed next to the file name is the index number of your measurement. Should you take several measurements in one session, the software will increment this number automatically, preventing possible loss of data. The checkboxes below correspond to the settings of your signal conditioner. The status of these checkboxes should reflect the actual settings of your signal conditioner. If your signal conditioner is set to high gain, then the high gain checkbox should have a tick mark. Similarly, if the correction knob is engaged on the signal conditioner, then the hardware correction checkbox should also be ticked. Engaging the correction knob of the signal conditioner will flatten the sensitivity of the sensor above 250 Hz. This option is not relevant for any measurements you may conduct with the Scan&Paint system. For all measurements it is recommended to turn the correction knob off. The exact influence of the correction knob on your sensor can be previewed either in the Scan&Paint settings window or in the calibration report delivered with your probe. The level monitor displays the current level of the acquired signals. The signal level on each channel of your data acquisition can be monitored here. The first two bars of the level monitor will always be related to signals measured by the PU probe. The remaining two bars tackle the data from any reference sensors you may connect to the system. Each bar of the level monitor is organized into 3 colors, which will inform you about its status. The blue color means that the current signal is too weak for accurate measurements. You should not start your measurement unless you are sure that the signal is strong enough throughout the whole time of your test. The easiest way to check the signal strength is to conduct a preliminary scan of the studied object while monitoring the signal levels. If the level monitor displays a green bar, then the acquired signals are strong enough for accurate measurements. Possible probe overloads or data acquisition overloads will be communicated with a red color on your level monitor. Additionally, red diodes will be turned on next to the overloaded channel. If after performing the preliminary scan you notice signal overloads, then you may need to adjust the sensitivity of your sensor. Switching the gain knob of your signal conditioner to low gain mode will decrease the sensitivity of your probe by a factor of 40 decibels. Although this method will definitely prevent any signal overloads, in some cases it may also reduce the signal strength too much. On such occasion we will need to adjust the sensitivity of the data acquisition device. This operation can be performed in the Edit menu under the DAC sensitivity option. In this window, you can adjust the input and output gain on all channels of your data acquisition. Increasing the input gain on any of the available channels will raise the signal level on that channel. Opposite effect will be observed whilst decreasing the input gain. Depending on the type of front-end supplied with the system, you may need to recalibrate your data acquisition device. This is necessary for the MF DAC2 type of device. Please remember that recalibration is only necessary if any changes to the input or output gain had been performed. To recalibrate your front end, go to the Edit menu and select the Calibrate DAC option. Next, press the Calibrate button located on the back plate of your device. The front end will now attempt to recalibrate itself automatically. If this process is successful, you will see a sine wave in the calibration window. If the level of all relevant signals is within the acceptable bounds, and the camera is positioned properly, we may now start our measurement. For the purpose of this tutorial, a 3-way loudspeaker is going to be studied. Pressing the Start button will begin the audio and video acquisition. To stop the measurement, press the Stop button. Total duration of your measurement can be monitored on the provided timer. The Scan&Paint system uses the recorded video footage to correlate the measurement points with the appropriate portions of the audio data. The process of probe tracking is based on color recognition. In order to enhance the tracking procedure, it is useful to single out your probe with a unique color. Since the color at the loudspeaker we are going to study is black, we will place a red marker on our probe. This marker ensures that the location of our probe will be more apparent to the tracking algorithm. Let's begin. While scanning a surface of any object, it is important to keep the distance from probe to surface on a constant level. Distance variations in the order of 1 centimeter will not significantly affect the accuracy of the obtained results. You may always trust the Scan&Paint to locate your sources accurately, even when keeping the exact distance is not possible. However, if you wish to compare several measurements together, then the distance probe surface becomes a relevant factor. As a rule of thumb, try to stay as close as possible to the measured surface. If during the scanning procedure you accidentally hit the measured object with your probe, you don't need to repeat your scan. All errors in the recorded signals can be excluded in the post-processing stage. Please remember that the microflown probe has a figure of 8 directivity pattern. This means that the probe is sensitive only in one direction. Let's consider an example. If a loudspeaker driven with white noise is positioned in front of the PU probe, that is rotated 360 degrees. Notice how the amplitude of particle velocity changes as the sensor is rotated. The same effect cannot be heard with the microphone. The microphone used in the PU probe is an omnidirectional sensor. Hence, its orientation is not relevant. You can always find the sensitive direction by looking at the red dot located on the connector attached to the probe. This dot should always be pointed to the measurement plane. You should avoid rotating the probe while scanning. The scanning procedure itself should be performed in a way that ensures the coverage of the whole surface of interest. Typically, 2 types of scans are recommended, the horizontal scan and the vertical scan. Combination of both types ensures proper spatial resolution in both the vertical and horizontal axis. The last topic related to the process of scanning is the velocity of the scan. Since the probe is moved in a time-stationary sound field, Doppler effect may introduce errors into the measured data. In order to have a quantitative assessment upon the impact of the Doppler effect, several scanning speeds have been tested. The frequency shift introduced into the recorded signal for different angle of incidences and frequencies is shown on the following charts. As can be seen, nonlinear effects are insignificant at scanning speed lower than 5 cm per second. The maximum error introduced at such speed is in the order of 1 Hz. Scanning speeds exceeding ½ meters per second should not be applied. The Scan&Paint software will allow you to calculate the velocity of your scan once your measurement is finished. This information can later be used to exclude data recorded while the scanning speed was too fast. Once the scan is finished, press the stop button and wait until the recorded data is stored on your hard drive. We may now move on to the second tab of the Scan&Paint software labeled as Process Video.